8x equals 512. 0.003062 equals 4x. How can we solve these?
Algebra.
So algebra, it's exactly what we need to do. Now looking at this, you guys might say, oh, I'll use the definition of log. Okay? So you might try definition of log, which says log of 512 equals x, right? Right? Does that one work?
No.
Yes.
No, why not?
That's base 10.
Good. This is base 10, and this is
Base 8.
base 8.
How do you
Does our calculator have a base 8 button?
No.
No. So you'll say, wait, I can't do that because it's not base 10. Okay? So what's another way? Well, part of getting questions right on tests is being a little bit resilient. If you do not know what to do at all, what's something you can try?
You give up.
No, we don't give up. What's something you can try?
You bug jam.
Algebra, you don't know the algebra steps, so what can we try? Ashley?
Oh, wait, I was going to say
X
this.
is numbers, right? So can we try plugging in numbers? Okay. Since 512 is bigger than 8, should I use positive or negative numbers?
Positive.
Positive. So try plugging in positive numbers for X. So 8 to the first, right? 8 to the second. Okay, try it out. See what we find. Yeah. Sure.
Oh, I got the answer, sir.
What is it, Elvin?
Yes, sir. It's 8 to the third.
It's 8 to the third. Good. So if you plug in numbers, 8 to the first is 8. 8 to the second is 64. 8 to the third is 512. That works. Right? So that one works. What about the other one? Should we use positive or negative numbers?
Negative.
Negative because we're less than 4, right?
Yes.
Okay. So it's like 4 to the negative 1, right? 4 to the negative 2.
That's good.
It's 4 to the negative 4.
It's 4 to the negative 4?
Wow.
Okay.
You're so smart.
So 4 to the negative 4 equals that. So x equals negative 4.
That's what
The
we have to do.
beginning numbers are the same, but then
They
they change.
change?
Yeah.
4 to the negative 4. 0.0039062. I just didn't have the 5 at the end, right? Okay, so it's fine. Alright. So 4 to the negative 4 works for that one, right? So that trial and error way, that works, but is that the way we should be doing these?
Yeah.
No.
We can. Okay.
But there's an equation.
The way we should be doing these is using the power property of logs. Okay, if you have that written down, that's fine. Okay, please leave that there, because if nothing else, it at least gives you a way to get close to your answer. Okay? But, second question. Why can't we just use the definition of log? We already said that, right, Gabby?
Yes.
Because these are not base 10, are they?
No.
This one's base
8.
8, this one's base
4.
4, so we can't use the definition of log. So we use something called the power property of logs. The power property of log says the log of 5 to the x equals x times the log of 5.
Oh.
The log of 5 to the x equals x times the log of 5. That's the power property of logs. On your notes it says power property of logarithm. Write that down. It's in bold.
Is it just 5x?
Anything. I just wrote 5x because there's usually a number there. Right? If I wrote A or B or C, then sometimes you get confused with what the variable is. Alright? 5 can be any number. It can be 10, it can be 30,000, it can be 0.001. Alright? It can be the variable y, it can be the variable a, whatever. 5 can be any number, but I just wanted to isolate the x because the x is what I'm trying to solve for. Okay? Yes, Udo.
Me and Alex have a question. What are we supposed to write?
What are you supposed to write? Okay, where it says power property of logs on your paper?
Yeah.
Okay, where it's bolded, about a third of the way down. Okay, this is the power property of logs. Okay? And what it does is it brings the exponent down. Right? In 8 to the x equals 512. Could I just solve this using algebra? Can I just divide by 8 and get the answer? No. Right? Can I just divide by 4 and get the answer? No. What you need to do is we need to log both sides because logging will bring the exponent down. Yes, I want you to write this down. You got notes on here. You guys. Alright? So when a variable is an exponent, log can be used to bring down the exponent, so algebra can be used to solve. Okay? Yes, I want you to write that all down.
Wait.
Where it says when a variable is an exponent, dot, dot, dot.
Gotcha.
Okay.
I don't know, he took the picture. Limits that will tell you?
That one doesn't have a backside?
No.
Oh, well, give me that one back.
Limits that will tell you?
Yeah, you're reading to kids in elementary school. Fine young students you are. Even though it's fourth grade. What? Can't see that. So I'll zoom in for it. You just want to get out of school. Have a good day, Mr. Branch. Better? Is that better, Nate? Okay. So when a variable is an exponent, log can be used to bring down the exponent. So algebra can be used to solve for the variable.
What do you mean by that?
I will show you. But Elvin, this kind of gives you a little preview. Log of 5x, we write as x log 5. Okay. This is an exponent, right?
Yeah.
Guys, this x right here is an exponent, right? Is this x an exponent?
Yeah.
No, it brought the exponent down.
That's all it does?
Yep, that's all it does.
Oh, that's all you have to do.
Well, not quite. Close, but that's how we get the exponent down.
Still
Okay.
have the exponent.
We still don't know what x is. We still got to solve for x using algebra. But it lets us, Alvin, it lets us get the x to a spot where we can solve for it. Okay, I can't solve for it as an exponent unless I'm in trial and error. Right? And trial and error won't always work. Okay? So we good on this? Okay. And we're going to put it back up there in a second. Alright, so 8x equals 512. We already know what x equals here, right? What does x equal? 3. What does x equal over here? -4. Okay. So if I'm going to use algebra to solve something, I have to do the same thing to both sides, right? Power property of log lets me bring down the x. So if I do the log of both sides, okay, then where does this x go?
Next to log.
Next to log. That's the power property of log right there. Okay. So now you can write these as decimals if you want to, but I'd say the best way to do these ones is keep them as logs. Alright? So what I mean by keep them as logs is divide both sides by the log of 8 and make sure you put it in parentheses. This is just like what we did in a class yesterday. So log 512.
The first number in parentheses.
The 512?
No, log 8. X log 8.
Oh, I didn't put in parentheses because you don't have to in here. The reason I put parentheses in here is to make sure you know that when you're typing your calculator, to close the parentheses. Okay? If you don't close the parentheses, you won't get the correct answer.
So we actually do log.
Log 512, close parenthesis, divide by log 8, close parenthesis. So type that in. Log 512, oh, I put 521. Divide by log 8. What is it? 3.
Hold on.
If you don't get 3, it's because you didn't close your parentheses.
I got 93.
Really? Okay. Okay, does that make sense? Does that make sense, guys?
Yes, sir.
Okay, the other one. What should I do to both sides?
Bring down the X. Log.
Need to bring down the x. I'm going to log both sides. You go 625.
No.
I'll put 5 there. Okay. So log of 4x. Right? So log 0.00396062 equals x log 4. Right? This power property brings the x down. Right?
Yes.
So now I divide by log 4.
Two separate numbers.
Divide by log 4. And make sure we do what, Nate?
Parentheses.
Put parentheses and close them, right? The log gives you that first one. You got to add the second one. Okay? So what does x equal? What does x equal? What was it, Nolan?
-4.
-4. Good. So this confirms what we found by trial and error. Right? Because you guys found that by trial and error. Now there's one more example they have on your notes. It says 6x equals like 3 billion. Oh, your note says it has a different number. Okay, your notes has like 110 billion. That number is incorrect. I don't know what I did wrong.
Did you do this last night?
I did it yesterday in 6th hour.
Oh, but you couldn't
So-
grade your test.
I probably, yeah, because teaching is more important than grading your test. All right, being prepared to teach is more important than your test grades. All right, so this number on your notes is 110 billion. Okay, change it to 362797056. All right, I know it's a big number. I picked a big number because I didn't want you to try to trial and error this. Because if you try to trial and error, you might get bored and stop. All right. I'm proving to you that this power property of log thing is valid and has value, and we should use it versus just trial and error things. Also, if x isn't a whole number, will the trial and error work? No. If x isn't a whole number, you can't do the trial and error either. All right, 1-8.
Slow down.
Okay, where are you at?
Still gotta figure out how you got B.
B. Just do log of 0.00396062 divided by log of 4.
You're so smart. All you have to do is work on being faster.
Come on, take it easy. Okay.
You go too slow.
It's getting heated in here, guys.
Shut up.
Why you been so
Got it.
mean to me lately?
Okay, we're good.
Sir, I got the
Okay.
He got the wrong answer because he's not moving.
You did that.
So, okay, big number go to front.
Well, now always, but the way this
I
is
got
set up.
11.
Okay. You already did it?
What?
Oh, I already had it.
All right. So,
She's not-
guys, Alvin, I am filming, so please keep your conversation involved with this.
Oh, that's nothing.
All right. So, to solve this one, what should we do first?
Bring on next.
We gotta bring down the x by logging both sides, right?
Yes, sir.
Okay. So we get x log 6 equals log of 362797056. Now on this one, and I know students sometimes you guys don't want to write down logs because you think it's quicker if you just write the decimals. All right. So instead of using the logs this time, guys, I want you to use the decimals and I want you to round to 4.
What do you mean decimal?
Type log of 6. What do you get for log of 6?
Do we have to?
0.7782, right? You might write that down, right? Log of 362797056. And you might write down 8.5597. Okay? So instead of doing the actual logs, I wrote them out as decimals this time.
Can we
Okay.
with the first one?
Yeah, I want you. I'm making a point.
Oh,
Okay? So now when I divide by 0.7782, we get x equals 8.5597 divided by 0.7782. We get 10.99.
Ooh, we got the wrong answer.
Okay, if I keep 4, it's 10.994. Right? Those that didn't use the decimals, because Gabby, I know you didn't use the decimal, right? Right? What'd you get for x? 11. Okay? The point I'm trying to make is if we don't use the logs, if we use just the decimals, what happens to our answer? It changes. It starts getting a little bit off. Okay, either smaller or bigger. Okay? And with exponents and powers and logs, those little small changes you're making to the 4th or 5th number have big effects on our answer. Okay? So the answer here is 11, and you get 11 if you divide by log 6 instead of doing it the other way. So if I divide by log 6 like this, you get x equals 11. All right? And I think that's a better answer than
are these always gonna be
10.994.
whole numbers?
They won't always be whole numbers. But if I use the logs instead of the decimals, all right, I'm more likely to get the whole number if there is one. All right, I'm more exact. So I think using logs is the best way to keep your answer exact. All right? Are there any questions? Nate, we good? Okay. Any other questions? All right. So the power property of logs brings down exponents. All right. So I think it's on the back. There's your first set of examples. Do we need to do a couple, or can you guys try them on your own?
I'm getting decimals. I don't know if that's right.
You can get some decimals. It's okay. All right, let's look at A and B then. Let me zoom in real quick. All right, so A. First step in A. What am I going to do?
Log each side.
Log both sides. So I'm going to get the log of 9x, 9 to the x equals the log of 65, 61. Power property says the x goes where? In the front. So x log 9 equals log of 65, 61. So now what do we do? Divide by log of 9. So x equals log 65, 61, and make sure we close our parentheses. Log of 65, 61, divide log of 9, and you get 4.
What? Whoa.
Did you close your parentheses, Gavin?
Yes.
Did you use decimals?
Oh.
You're doing this one.
Yeah, I know. I already did that. I know we're talking about 8 interceptions. What?
By frat number. Okay. All right. Any questions about that one? KB, what's the first step?
Log each side.
Log each side. Yep. Yeah, if you want, that's fine.
Really? I don't do stuff?
So, x log 3 equals log 33, right? So what do we do now? Divide by log 3.
What do you get? 30, 11?
Nope.
I got 3.1. 8. 7.
Zach.
So log 33 divide by log 3.
3.18265.
I forgot to close my parenthesis.
Drawn into the 7.
3.1826. So it's 3.18265, and it keeps going, right? Now if I tell you to keep 4, then the 5 makes the 6 into a 7. Okay. So can we get decimals? Yeah. Would you have been able to trial and error B?
Yeah.
No, you cannot trial and error B. That'd take forever. Okay.
Forever we have until forever ends.
All right. All right. I want you guys to try C, D, E, F, G, and H. Try them on your own. Okay.
It's